hydrochloric acid in there, yeah?
Yeah.
What's in here? Just water?
Yeah. Okay, you need quite a long chunk of magnesium ribbon. Okay, now the first time, if you're just topping it up, whoops, get in there. If you're just topping it up with a bit more magnesium ribbon, okay, then it's not too bad. But the first time you put the magnesium ribbon in, obviously you've got to wait until it blows all of the air out. So you don't want to get the kids to collect the first bit. Alright? Then, put your foam canister in there, okay, stick the delivery tube underneath, and we're going for 2 parts hydrogen, 1 part oxygen for the full stoichiometric mix. There we go.
2 parts.
2 parts hydrogen, 1 part oxygen. Right, and then I've just got the oxygen on very slow bubble there. Fill up the rest with oxygen. Great, that's it. Alright, put the lid on, got to do it all underwater. Put the lid on.
Is there water in there as well? No?
No, it shouldn't be.
Keep it manually.
Right, and that's the cool thing, you can show it to the kids and go, can you see the water? And they're like, no. You're like, well, there's hydrogen and oxygen in there, so how are we going to make water out of it? Okay, we need a little spark. Alright, if you hold it down, flip it off with your thumb. The reason that you're holding it down is so that the hydrogen doesn't escape, so you take it off. Get it on there. When you're doing it with them, it's really important. It's really important that
to not point it my way.
Don't point it at anyone. And what I do is I get them coming out 3 at a time to fire them, and I get the whole class behind there. Okay, and it's just those people, and then that's good, isn't it?
Well, why does it explode?
You like it, yeah.
So why is it exploding?
Hydrogen, oxygen,
just
little
explosive.
bit of heat to start
So
the
where's our
reaction.
water then?
Bang.
Where's our water vapor?
You go and have a look over there, mate. It's in there. It's in
Let me
there.
have a look. Is it in there? I think we should see some water vapor condensing somewhere.
Right, will you fire it in somewhere where you can collect it?
Alright, this
Cool,
one's
isn't it?
good. This one's going to take a little
That's
bit
good.
longer. Okay. Can somebody do that and get some? Just fair guys.
I'm obstructing the video here, Dev.
Squirts of soap and then put about 1 inch of water in it. Right, this is going to take ages because it does.
I'll just think what to order better.
Okay, Corey, I'm going to need a hand. Matt, I'm going to need a hand. So here's the good thing about this experiment is it's not guaranteed. So you can get loads of people involved. One of them is you're doing a reaction between hydrogen and oxygen. So with one flask, you're going to make hydrogen by doing another metal acid reaction, and with the other one, you're going to make oxygen by decomposing hydrogen peroxide. Okay, brilliant. Okay, so what we're going to do is we're going to get a load of zit granules in one. Okay, to that we're going to add our acid. Okay, but because the zinc has an oxide layer on it, you need to add a dash of copper sulfate that goes through the oxide. Okay, otherwise it doesn't work. I'll write it on.
Last chemist here, meddling around.
We'll write it all down. Okay, so into that one goes some acid. Okay,
So what acid is this?
hydrochloric acid. Yeah.
So
What, 1 molar?
Okay, so you're going to get hydrogen produced. Okay, that's 2 molar.
2 molar.
In the other one, this is a messy bit, we're going to get some manganese oxide powder, and you need quite a lot of this because it gets used up quite quickly in the reaction, and it's quite messy, so you've got to be careful. So manganese oxide powder in there, so manganese dioxide. Okay. And then the 2 volunteers. And the good thing is, while you're doing this, you could take half an hour on this. It depends whether you're doing key stage 3 or key stage 4, because then you can talk about decomposition reactions, salt production, metal acid reactions, equations. If you want, you could do equations for what's going on in each particular situation. In there, then we're going to get our hydrogen peroxide. Okay. That's what it's like. Okay. In here, what we're going to do then is in this one produce hydrogen, in this one produce oxygen, and mix them together in this one. So in here, Alex, if you do the paper, top that up with
Pour that into there.
about that much water. No, just make sure they're nice and secure on there. So you get one student working here, another student working here, and they need to know what they're doing, because a lot of the time you say, I need more hydrogen, and they won't know, they'll start looking at each other. So you just need to make, even if you want to put a big H there and a big H on the paper, easy. Okay, so you want to produce, they need to know. So you can get one student here, one student helping you there. Corey, could you do us a favour and grab us some splits? Grab a whole, as many as there are. Brilliant. So you're going to need one person on your Bunsen burner lighting splits for you. Okay, so Matt, can you give us a hand with this? Yeah. So Alex and Corey, if you come around here, and Matt or somebody, just one. I need one person there, one person there, one person there.
Dark oxygen.
Okay, you need to just make sure that these don't kink, so otherwise. Okay. Corey, can you light up splits for me? What I need you to do, Corey, is just keep coming at me with splits. So when we hit and pass me one, right in the back.
Okay.
Okay, right, not yet. Okay, let's have some, you're making hydrogen, you're making oxygen. So what you need to be careful is that fizzes up and fizzes up and fizzes up and end up coming down.
So I'm going to stop that.
So you've got to do it only a little bit. Okay, let's have some hydrogen, please, Matt. So let it run for a little while. That's it. Okay. Okay, is it coming up? Bubbling?
Yeah.
Nicely?
Good.
Okay, just wait a little while until we get the hydrogen over there. See, the hydrogen's being mixed up in here now, yeah? And a little bit of pressure has popped that open now. You see the pressure in those tubes. Okay? So now let's have a tiny bit. You only need to do a little bit because it goes up really quick. So a tiny bit of oxygen. Okay? Now there's oxygen coming here. Now I can create my bubbles in here. Light this up. Now you've got to be careful with making too big a bubble. The bigger the bubble, obviously, the louder the bang. Now, at first, students are just going to say, oh, nothing happening. Yeah? And like there isn't, there's really nothing happening. Okay, you know what? Oh, way too much oxygen. Okay, that's the problem, that's the problem. That's why we need to stop. Okay.
I stopped looking, I was looking at the bubble.
Okay.
I apologise.
It's not gonna happen then. Anyway, the good thing about this is, unlike maths, which is a definite bang, it's not going to happen.
Alex.
Don't worry, next time we do it.
You can see where, you can now see the problem somehow.
Yeah, we can now, there's a demonstration of what can go wrong.
Okay, well this is the good thing, is that there's lots of different things that can go wrong. And sometimes nothing is going to happen. And the loudest bang you'll get is, I mean literally that loud. But sometimes...
Does that actually have to bubble through that?
Yeah.
Yeah.
How do you mean, bubble?
I mean the tubes have got to be dipping.
Yeah, they've got to be in... No, well they don't have to.
Right.
When you show both tubes going there, it shows that the gas are coming into there.
Right.
Okay,
this is
so the
purely
liquid's
visual.
just there to show.
This is purely visual. You don't need any of this if you don't want. You can just have these two and that's it. But this is a place for them to mix, and it's a visual thing so they can see it mix. Yeah?
Yeah.
So what you're always going to find is this has happened to me 4 or 5 times. So I wouldn't worry about it. Yeah?
But you're the worst student you've
Yeah,
ever had.
I know.
But
that happens. So the thing you're going to have to watch with this is that will carry on going for the next 20 to 25 minutes. That will keep going. You don't need to touch it. Or you might need to top it a little bit. This one gets ruined all the time, and I've done it myself several times. So don't worry.
So you'll bubble it in to try and produce quite big bubbles,
Okay,
yeah?
you just want a few bubbles like there are there, okay? It can sometimes gradually get louder to the point where it will get so loud that it will make people's ears ring, and that's when you need to stop. Don't be tempted, no matter how much the kids will say, is go bigger bubbles, so you've got bubbles like that. Because believe me, if there's a little bubbles like that big can make your ears ring. If you start trying to be brave and clever and stuff like that in front of them, then you're going to
So what, is that about as big as the bubble you go for?
You'll start moving stuff, literally.
Like, with that
I wouldn't
big?
go much bigger than that.
Right,
But it's up to you. You'll feel the build-up to it, and it'll gradually get louder and louder and louder to the point where you'll see their looks from fun on their faces to actually getting a little bit of pain.
And that's
No,
what you need to
seriously.
see, yeah.
Well, Well, I can only apologise.
No worries, no worries. Should we get this one then? This one's quite cool. Ready? Come on, here. Right, this is quite a simple one, but a dangerous one.
Okay, you done with the button?
Yeah, no, yeah, cheers, just to knock it up. Right, I'm going to show you some reaction between, is there any foil in there? Well, can one of you guys use the foil and grab us some foil? There should be no foil. We'll check on the other trolley. There's no foil on that trolley, is there?
No.
Like some kitchen foil, aluminium foil.